right, this is to help walk through the calculation for part C of constant pressure calorimetry experiment. All right, so in experiment C, what you did is you heated up a metal and you heat it up by putting it in a test tube and then having that tube in boiling water for a fair amount of time. Took the temperature of that metal, figured out what the initial temperature of the metal was. Then you added that hot metal into your calorimeter, aka your coffee cup, your styrofoam cup, that was filled with about 50 milliliters of water. And you waited until that the water temperature became constant. So you monitored the change in temperature of both the metal over time and the water over time. Okay. The question, or what you need to solve for, is what's the specific heat capacity for your metal? And that's what part 3 is wanting you to do. And just like in parts A and parts B, we're just looking at simple heat transfer. So hot metal was added to lukewarm water, and the water warmed up and the metal cooled down. So heat was transferred from the metal to the water. Okay, so if the metal was releasing the heat to the water, that would be an exothermic process. So the Q of the metal, the amount of heat, right? Q is the variable for heat, would be negative. And since the water was gaining temperature, the heat, right? We saw the temperature increase. The sign for the heat for water would be positive. Okay. So you need to solve for what is the specific heat capacity of the metal, okay? So this time, what we're gonna do is we're gonna expand out both of these Q's, knowing that Q is equal to specific heat capacity times mass times change in temperature, okay? So we just gotta keep our subscripts in order here. So if I expand out this Q here, I would say negative specific heat capacity of the metal times the mass of the metal times the delta T of the metal would equal, I'm going to run out of space for sure, so I'm just going to write it down here on the line below. The specific heat capacity of the water times the mass of the water times the change in temperature of the water. Okay? Remember that change in temperature is always temperature final minus temperature initial. Okay. So, do you know the change in temperature of the water? Yes, you do, because you got the value before and after. You know, before you added the hot metal, and then after, once the temperature equilibrated when you had the metal and the water mixed. Do you know the mass of the water? Yes, you do, because you know how many milliliters of water you added to your experiment. Do you know the specific heat capacity of the water? Yes, you do. It's a constant. That's going to be 1 calorie per gram degree Celsius. Okay. Do you know the change in temperature of the metal? Yes, you do, because you measured the metal before you added it, and it was really hot, about 80-ish, 90-ish degrees. And then you know what the temperature was of the water and metal mixture once it equilibrated and stopped moving around. So that was the final temperature. Do you know the mass of the metal? Yes, you do, because you weighed the metal. And if you didn't, then I don't know what to tell you. But so you know all of these values, but you don't know what the specific heat capacity is of the metal. So you can see that this is a simple plug and chug where you would have, you know, heat capacity is your unknown, but you have a number here, and that equals this number multiplied by that number multiplied by that number. Okay. And so that is how you solve for specific heat capacity of the metal in this experiment, part C. If you have additional questions, make sure you can post them on the discussion board.